we're going to look at that binomial distributions of discrete. How do we know it's discrete? How do we know these examples? Because when you look at your formula sheet, it's not going to tell you discrete, whatever, you've got to figure that out yourself. How do you know this is a discrete probability? What's discrete data? What do you reckon, Riley? If you've got shoe size versus foot length, one of those is discrete, one of those is continuous. Foot length is continuous because your foot length can be 13.7346 whatever centimetres. Your shoe size can only be 8, 8.5, 9. So it's got clear levels or clear discrete intervals in which it works. This problem is clearly a discrete problem because can you get half of a shot in? You can only get a full shot in, correct? So we know we're dealing with discrete data, which means we get this formula here. When we go to our formula sheet, we see this and we go, great, what does that mean? So the first thing is to write the formula down and identify that we've got some variables here. What are the variables we're looking at? What are the variables that we have here? What are the things in this formula that we don't know what they mean? There's only three. P, R,
N.
and N. So we need to find that information in the question. So when we're reading the question, we need to look for a probability of success. Can we see that in this question? Can we see the probability of success in the question where he's got to get 4 shots? What is the probability of success? What if it was represented as 60%? Could we put 60% in? What would happen to our answer if we look at this? Would it be different?
Yeah.
Vastly different. So we need to make sure that our probability is in decimal form. So when I see 1 minus P, that's simply talking about the probability of? Yeah, not success. Because 1's 100%, so the probability of success, 1 take that will give us the probability of failure. Sweet? Or not hitting the shot. R represents the number of successful attempts, and N represents the number of attempts in total. So then the only thing we've really got left that we're not sure on is this. Now we can see in this formula here, X equals R, so that's probably telling us what R stands for. Would it make sense if X equals N there?
No.
Because that'd be essentially saying, I take 6 shots, what's the probability I take 6 shots? Does that make any sense at all? So clearly, that R is talking about the number of successes. So if you forget in your exam and you're not sure what they mean, that should tell us. We remember from last year that this is simply a representation of our combinations, NCR. For those of us who can't remember what that equals n factorial divided by n minus r factorial times r factorial. You may need to know that. Why would you need to know that? For a tech-free exam. And with these, they can be aware with factorials, cancelling out must take place. But these can be a bit tricky. I would expect R would be 2 or 4 or something. You'd have something multiplied by 2 factorial on the bottom, I would guess, at the largest value. So once we know that, thankfully most of our binomial problems come in tech active. So we pull out our calculator and we see that we need to go to a probability. For those of us who have forgotten, we turn it on first of all, we click option and then we click prob. We should be in the run maths. So if we click option, you might have to go across to find probability and look for the NCR. Now when you hit that, it doesn't come up like this, it just comes up as the letter C. You put N before and you put R afterwards. So our equation, when we put it in our calculator, should look something like this. Other way around. And that's all we have to do. If it was tech free, you might have to leave these in fractional form. As a fraction. So you can actually do that mathematics. But this is clearly impossible to do without a calculator. So this would be a tech active question. So I want you to practice shoving that in, and you should get 0.3114 or something. I don't know what it is. Now later on, they're going to ask you to determine the probability that x is no more than 3. So just be fully aware that in the next set of questions, you're going to be asked to determine the probability that x is less than or equal to 3. What's the problem with that? Look at our formula sheet if we're not sure.
So do you have any exact formula sheet?
Can't be. You just grab this later.
You just have to add the individual probability.
Yeah, the problem with this is because it's not continuous, we haven't got the option of a formula that works for less than or greater than. So the way that we have to do it is by adding up the individual probabilities. But that gets quite cumbersome. Why does it get quite cumbersome? Because every one of those, to get every individual one of those, I've got to do this. I have to repeat that process for every single one of those. So if I can cut a corner, I'm all about that. So I can also represent that as 1 minus px equals 4 plus px equals 5 plus px equals 6. And in this case, that's a lot better because I've already got one of those values. So I only need to find 2 extras. Sweet. If you want a hint for doing this, keep that saved in your calculator and then go through and change your n and your r, or your r is the only thing it changes. So that becomes 551,660. And then you should be able to pump out your formula, your answers pretty quickly. Sweet. Why is it 1 minus that? Because I can either add up all the individual probabilities, or I can say 1 minus the probability that doesn't occur. So these are all the other possible scenarios. Yeah.
What if it's asking you to calculate the probability that there was no less than 5 shots?
Less than 5 shots. So in that situation, you want px is less than 5, which could also be 1 minus the probability that x is greater than or equal to 5. And then you go 1 minus p equals 5.
I don't like those.
Sweet.
Which question?
Or you could go 0, 1, 2, 3, 4. Up to you.